This video is going to be talking about composite functions in addition to inverses. We're going to start with composite functions. A composite function is taking two functions at the same time, so they're both dealing with the same independent variable. So you'll see notation such as f of g of x, and that is the same exact notation as f following g of x. So it's two functions that are going to be using the same independent variable x. Order is going to be very important. If you look at this first equation, the left-hand side, first it's the g of x part first. That new result is the x, is the new independent variable in our f equation. The same thing is here. That's why it's f following g of x. So you take care of the g function first, and then you apply the f. So we're going to look at one more way of writing it. You'll see this in some textbooks, f following g, then such that x maps onto f of g of x. Again, just one more notation that you're going to see. So we're going to look at some examples, and we're going to work through them and see what happens when we do a composite. So this is the example we're going to look at. F of x equals x to the fourth, and g of x equals 2x plus 3. With those two functions, we are going to do two things. We can do many things. We're going to first find f of g of x. After we do that, we are then going to do g of f of x. I could also do f of x or g of x, or put numbers in there, do all of that kind of things. But we want to look at just these two so we can see what takes place with my new function, possible new function, I should say. So if I do f of g of x, I start with my g of x. That's the starting point. This is g of x. So this g of x we know is 2x plus 3. So now, f of g of x is the same thing as f of 2x plus 3, because 2x plus 3 is the same thing as g of x. Now, this 2x plus 3 we treat as if this is the independent variable in my f equation. So now I go back up to my f, and it says x to the fourth. So this 2x plus 3 is now going to go in place of x. So therefore, when I perform my f function onto it, it's 2x plus 3, because that's my new x value, to the fourth. And then I can go out and expand that. And if you know the binomial formula or you remember the expansion, it definitely is much quicker. Which, if I did my math right when I expanded it, is 16x to the fourth plus 96x cubed plus 216x squared plus 216x plus 81. So that's f of g of x. So now we're going to do g of f of x. So now it's g following my f of x. F of x was x to the fourth, so it's g of x to the fourth. So in my g equation, wherever there's an x, I'm going to put x to the fourth. So it's 2, then there's an x, so that's x to the fourth, plus 3. So f of g of x and g of f of x are two different equations. They're both fourth degree, but they are two separate equations. Now, we're going to look at another example and see what happens with that one. So now I have the two equations, f of x equals 3x minus 5, and g of x equals 1/3 x plus 5/3. So I'm going to do the same thing as before. I'm going to compute f of g of x, and then I'm going to compute g of f of x. Now, even though we're working with fractions, it doesn't make it any more difficult. Some of our numbers might not always come out as nice, but it doesn't mean that our final result is going to be bad. So to begin with, f of g of x, so we're going to start with our f equation, and wherever there's an x, the whole g of x quantity goes in there, because it's f of 1/3 x plus 5/3. So therefore, my f equation, this ends up representing 3 times the quantity, 1/3 x plus 5/3, because that was my x, minus 5. So I have to go through and simplify. And when I simplify this, I multiply the 3 through, which is nice, gets rid of all those fractions. That's why I said sometimes some nice things happen. So I get 3 times 1/3, which is 1, so it's x, plus 3 times 5/3 is 5. And then I still have this subtracting 5. Therefore, I get simply x. So f of g of x in this case simplified nicely, and we ended up with x. If I do g of f of x, if you remember in the last example, f of g of x and g of f of x were both different. So now I'm going to do g of f of x. If I do g of f of x, it's g of my f of x, which is 3x minus 5. So then I'm going to plug that in place of my x for my g's, which gives me a result of 1/3 times the quantity 3x minus 5 plus 5/3. Now I distribute the 1/3 through, so I get x minus 5/3, and then I still have this plus 5/3. Well, one's negative, one's positive. I get x. Both results, f of g of x and g of f of x, they both resulted in x. This is a special case. This does not happen all the time, as we saw earlier, 2 different solutions when I did my composites. In this case, not only do I get the same value, but I get x. Just x. One way might be a little easier to figure out than the other. F of g of x might be easier than g of f of x. It completely depends upon the equations. However, if that end result is x, if I take f of g of x or take g of f of x, those two functions undo each other, and those are called inverses. So after we do the composite, if we end up getting x, it is an inverse. There are a few restrictions that happen with inverses, or some key things you should know about. A function may not have an inverse. So you may be given an equation, and there may not be an inverse function, I should say. It's not going to be, it might not be an inverse function, FNC function. If an inverse exists, there are some things that have to happen. Okay, so if the inverse of that function exists, A, it must pass the vertical line test. B, it is a reflection in the line y equals x. And lastly, if I take the composite f of f inverse of x, that's our inverse notation, if I take the composite, it has to equal x, whether I do it this way or if I do f inverse of f of x. Because as we saw earlier, it does not matter in which way we do the composite, you're going to get x if they are inverses. One other thing that you will see with inverses is the domain and range. Now think about what domain and range represent. If I'm looking at the domain of f inverse, that is the same thing as the range of f. Because all we're doing is we're looking at these two scenarios as inverses of each other. They reflect over the line y equals x. If they reflect over the line y equals x, their x values become their y values become their x values. So therefore, if I'm going to look at the domain of your inverse, well, the inverse and your initial function, those switch x and y. Well, domain is usually your x, range is usually your y. Those two are therefore going to flip. So then the same thing can be said about the range. So the range of f inverse is the domain of f. And you can think of it both ways. You don't have to start looking at your inverse. You could start looking at your f and then figure out your inverse based on that. So you're going to be flipping your x value and your y value. So we're going to do some practice actually finding inverses. So we're going to start with the linear equation f of x equals 2x plus 3, and we want to find the inverse. So to find the inverse, I'm going to rewrite it as y equals, just to make notation a little bit easier. The inverse switches your x and y. So x equals 2y, plus 3. Solve for your y, subtract the 3, divide by 2. So therefore y equals, same thing as 1/2 x minus 3/2. And I did ask for f inverse. We can't leave it in terms of y. So it's going to be instead f inverse of x equals 1/2 x minus 3/2. So now we found the inverse of our initial function. To do a quick check, we need to take our composite, f of g of x, or in this case, f of f inverse of x, or f inverse of f of x, either way, and then make sure that we get x. So do one way, it does not matter which way you do. So I'm going to do f inverse of f of x. So therefore f of x is my control, so f inverse of 2x plus 3. And feel free to do it the other way as well if it's an easier computation for you. So in my f inverse, wherever there's an x, 2x plus 3 is going to go in place of that. And then simplify. And it simplifies to x. Again, either direction you go, you will get x. Shortcut it, calculate one of those. So hopefully this helps you understand the composite and how inverses fit in along with your composites.